In today's note, we'll be looking at the volume of pyramids and cones. So pyramid, if you can imagine the pyramids in Egypt, they're 3D shapes that come to a point, and the side faces are triangles. A cone, you can think of something like an ice cream cone. It has a circle as a base, and it tapers to a point. So if we were to imagine kind of a cylinder, think of kind of like a pop can, and if we were to imagine a cone that had the same dimensions as our cylinder, if we wanted to figure out how many cones could we use to fill up that cylinder, we would see that exactly 3 cones will fill a cylinder of similar dimensions. And we can see that relationship in our formula for the volume of a cone, as we can see our cylinder formula, and then we just take that and divide it by 3. Similar to a square-based pyramid, we have kind of the volume formula for a rectangular prism, and we're dividing it by 3. Again, you don't need to worry too much about that. That's just more background on where the formulas come from and how they were discovered. So our first question is looking at determining the volume of our cone. So if we see our cone here, we're going to be using our formula. So V equals pi r cubed, r squared h, and we're going to divide that by 3. So pi 3.14 times my radius. Now the radius, remember, is from the center to the outside. I'm given the diameter, so I just need to divide that by 2 to find my radius. So in this case, it would be 5. So 5 squared times my height, which is 15, and I'm going to divide by 3. So if I go through 3.14 times 5 squared times 15, I'll get 1,177.5, and I'm going to divide that by 3, and I get 392.5 centimeters cubed, because we're dealing with volume. If I look at example 2, I have a square-based pyramid. Square base means all the sides on the base are the same, so 5 and 5, and I want to find the volume. So V equals base times height divided by 3. So 5 times my height, which is 20, divided all by 3. So I get 500 divided by 3. And I get 166.6 repeating centimeters cubed. And that would be the volume of my square-based pyramid. And lastly, my last question, another square-based pyramid, and I want to find the volume. Now, what's different about this one is that I'm not given the height here. However, I am given enough information to find that height. And if I look at this line here and this line going up the face, I can see a right angled triangle forming. And I know, if I look back at my Pythagorean theorem note, if that's my triangle that I have in red, I can figure out that unknown side by using the Pythagorean theorem. So in this case, we do a squared equals c squared minus b squared, because I'm finding a leg. So a squared equals 10 squared minus 3 squared. A squared equals 100 minus 9. A equals 91. And again, our last step, we have to square root a number, so square root 91, A equals 9.5. So that means my height is 9.5. Now I have enough information to use my volume formula. V equals base times height divided by 3. So V would equal one side length here, so 6 times 9.5 divided by 3. V equals 342 divided by 3. V equals 171 centimeters cubed if you're dealing with volume. So that's how we can find the volume of cones and pyramids.